Hello, everyone, and welcome to Section 14.10. This is on mass spectrometry and more specifically analyzing the M+1 molecular ion peak. First thing we should do is remember something from our general chemistry textbooks, and that is that carbon has two types of isotopes. It has carbon-12 and carbon-13. Because carbon has two types of isotopes and there's a natural abundance of these isotopes of 98.9% of carbon-12 and 1.1% of carbon-13, this affects what we see in the mass spectrometer because remember, we're seeing masses of ions as they come through the instrument. So if we have our mass spectrometer output here and we have M over Z, we have percent abundance on the y-axis, and we have M over Z on the x-axis. We'll go as we're getting bigger here, 20, 30. So if we have ethane, C2H6, the abundance of the one with two carbons, C2H6 has a molecular weight of 30, so it's 24 and 6, so it's like 30. So 30 would have an abundance very near 100, but not totally 100. And in fact, you would have 2% of 31 because of that extra 1.1% of 13C. And in fact, for every carbon that is present in your molecule, we will increase the M+1 molecular ion peak by 1. So for instance, if you had 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. This is heptane. Heptane is C7H14. This is equal to 84 plus 4, 98. So that means looking at the percent abundance versus M over Z. If you have 90, 95, 100 here on the x-axis, that means 98 is going to be only now 90%, and 10% is going to be 96. And this will hold for all molecules that have carbons in there as well. So remember, when you're looking at the M+1 molecular ion peak, that's going to tell you how many carbons are present if you can make out the percentage that is present, or if you can make out the relative percentage of the M+1 peak versus the molecular ion peak. So this was section 14.10.